friends, hope all you guys are doing pretty well. Today we'll solve a tricky triangle question, and we have taken up this question because this question involves many theorems that are mentioned in the triangle chapter. So once we solve this question, actually we can deeply understand the how these theorems of triangle are actually applied in a practical solution to a problem. So here we see the question says, you can see the figure, the medians BD and CE, the medians BD and CE of a triangle ABC, this is triangle ABC, meet at G. You can see that, meet at G. So prove that EZD is EZD is similar to CZB, you can see that, and BG is equal to 2GT. So let's solve this. So if I think that you are able to, I hope that you are able to understand the question. It's pretty clear. It is related to similarity of a triangle problem, and it says that EZD equals to EZD is equals to CZB. So this is the triangle. We have to prove that these two triangles are similar, okay, and BZ and BG, this one is equal to 2GD. Okay, so let's solve this. So let's apply the midpoint theorem. Okay, we already have studied the midpoint theorem. What the midpoint theorem says, if BD is the median, then D is the midpoint of AC. Look at the triangle. If BD is the median, then D is the midpoint of AC. Yes, if the median divides the AC side into two halves. Okay. Similarly, if E is the midpoint of AB, okay, then what does it says? That it also divides AB into two parts. Okay. So now if you can remember the midpoint theorem, what the midpoint theorem says, if the line segment joining the midpoints of two sides of a triangle is parallel to the third line and equal to half of it. It means that it says that if the line segment, here the line segment is ED, okay, joining the median point of two sides is actually parallel to the third side. It means ED is parallel to BC, because ED is the line, E is the midpoint of AB, and D is the midpoint of AC, okay, and ED is the line which is, when we join it, the midpoint theorem says that ED is parallel to BC. Hope you remember that midpoint theorem. If you don't understand, please comment. We can take a session on that. And also, according to midpoint theorem, ED is equal to half BC. It means this line segment ED is actually half of BC. Yes or not? This is half of BC. ED is half of BC. Okay. So this is the midpoint theorem. So let's prove that. What is the first thing we have to prove? EZD is equals to CZB. So let's solve it. Okay. So now compare EZD two triangles, EZD and CZB. Okay. So can you solve it? Yes, your guess is right. This angle is equals to this angle. Okay. EZD is equal to BGC. Why? Because these are vertically opposite angles. Correct. Okay. Then if GD is equal to GCB, GD is equal to GCB, GED, this one is equal to GCB. Yes or not? Why? Why is that? Yes, because this is alternate interior angles. Since ED is parallel to BC, since ED is parallel to BC and is a transversal, yes or not? CE is a transversal, okay, then the alternate angles are similar. So this is something like this. Okay. So two parallel lines, this is ED and this is BC. Okay, this is the transversal. This transversal here is EC. Okay, then what happens? This is the this angle is equal to this angle. Okay, look at that. So GD is equal to GCB. GED equal to GCB. Yes or not? Okay, so you got it. So this is the alternate interior angle. Similarly, GDE is equal to GBC also. GDE is equal to GBC. The same thing. Okay, ED is parallel to BC and BD is the transversal. So the interior angles are similar. That's why GDE is equal to GB. So in the two triangles, if you mark the three angles, okay, the corresponding three angles are actually similar. Yes or not? In EZD, the the angle EZD is equal to CGB because these are vertically opposite. Okay, this angle DEG or GED is equal to GCB. Yes or not? Because alternate interior angle. Then EDG is equal to GBC because this is also alternate interior angles and BT is a transversal. So the corresponding three angles are actually similar. So what is the principle that will be followed? Angle similarity criterion, because three angles are the corresponding angles are similar. So if three angles corresponding angles are similar, then triangle EZD is similar to CGB. Triangle EZD equal to CGB. This is the first thing we have already proved. Okay. Then we have to prove that BZ is equal to 2GD. BZ, this line segment, is 2GD. Okay. It means the BZ is actually double the size of GD. So how can you do that? Yes, because you have already proved these two triangles are similar. Two triangles are similar means the ratio of the corresponding side must be equal also. Yes, we have already studied it. GD by GB. GD by GB is equal to GE by GC. Yes or not? Correct. You got it right. Okay. Then what do we get? Okay. If from step 1 of the midpoint theorem, what we have already known, that ED is equal to half of BC. We know that ED is equal to half of BC. That is the midpoint theorem. We have proved that what is the situation in which ED will be parallel to BC, and if ED becomes parallel to BC, it means that ED is half of BC. So it's just algebra. ED is equal to half of BC. It means ED by BC is equal to half. ED by BC is equal to half. Okay. So substitute this value into the side ratio equation, because we have already said ED by BC is equal to GD by GB. Okay. So instead of ED by BC, we can say GD by GB is equal to half. So GB is equal to 2GD, or so here in GB same BG is equal to 2GD, that has been asked. So first, similar, we have to prove that the two triangles are similar. EZD triangle is equal to CGB triangle. We have already proved it because angle similarity principle criteria has been applied, and so we find out those criteria are being matched. So that's why these two triangles are similar. Then we have also proved that BZ, this line segment, is twice the size of 2GD. This is also simple algebra. So here you can see all the midpoint theorem, the similarity theorem, okay, and the smart algebra question has been asked in this small 3-liner or a 4-liner. So it's always prescribed that for geometry the concept should be clear and the student should visualize the theorems through diagram properly. Then we can solve any kind of tricky question related to whether triangle or circle or any other or in coordinate geometry. Thanks a lot. Hope you have enjoyed this problem solving of a triangle problem. If you have any doubt or if you want any question to be solved, please let us know. We'll feature that in next videos. Thanks a lot. Thank you.